So title of my talk right now, I kind of changed it. It's just kind of whatever happens, happens. We're going with the flow. I was going to talk only about Kubernetes, but I'm getting a lot of questions from people about the plugin stuff. So I'm going to briefly touch on Kubernetes and then leave some details to Mr. Ian Lum, who's going to be going, I think, right after me. And then I'm going to talk about the plugin architecture because I think it's kind of cool. So I hope I didn't offend you, Greg. Sorry. So Kubernetes, what is it? What's the difference between microservices and compute? And kind of what are we doing to bridge that gap there, right? So you have your traditional container runtimes, and they work great for microservices. They have this layered image format that's great for development iteration, but they're maybe not as optimized for production workflows, production deployments, machine learning, et cetera, like that. And Singularity, as you guys probably already know, was designed specifically for these use cases. So the question that we've tried to answer is, can we run services and compute as a unified solution at the same time by using Singularity under Kubernetes? So Singularity is optimized for these compute workloads. Kubernetes was built from the ground up for microservices. If we can combine the two, do we get the best of both worlds, right? Can we run our microservices and do our compute workloads? So I'm hoping the answer here is yes. What we've kind of been working on essentially is building up a CRI for Singularity. So right now that's in the second alpha release, I believe, and it works. You can go and run your Kubernetes deployments using Singularity as the underlying technology. You can run your SIF. Everything works almost exactly as expected from a standard Kubernetes point of view. And we're doing some work right now to sort of take this Singularity CRI and make it a little more like the traditional Singularity runtime that you're used to. One other thing that I kind of want to touch about with the Singularity CRI, our goal is to sort of tightly couple integration with devices to the runtime, because that's sort of a Singularity thing that people have come to expect. For example, the --NV flag, we want that to basically be bundled with the Singularity CRI in some way so that people can do the Singularity workloads that they're already doing and that they expect to work just kind of right out of the box. And as you can see here, we're passing something like 72 out of 74 of the CRI validation tests. So it's working pretty much as you would expect. This is a slightly old picture from the spreadsheet that we've been tracking the progress there. I think we passed like those two there now, or these two here, I guess, actually. So now what I want to talk about in a little bit more depth, which is coming out very soon. So the target release date for Singularity 3.2 is April 9th. Thumbs up. And that's including a plugin system. So let's talk a little bit about the plugin system. Genius, right? What? Yeah. So a Singularity plugin, it's made up from 3 components right now, right? So there's a manifest, which basically is including what is the name of the plugin, who is the author of the plugin, description of the plugin, and version of the plugin. And these are all controlled independently from Singularity. So it's not tied to the Singularity version, but rather it's the version of the plugin. The second component is there's what we've kind of called just an initializer interface. It's for those of you who are using Go, it's literally just an interface called initializer. And this is where your plugin essentially will do all the work to like register what different hooks and functions it's going to expose to Singularity and vice versa. And then there's also a config interface. I think this is pretty cool. So within this plugin type, as you'll see here in a second, I actually have the plugin type right there. There's another interface called the config interface. And you just put a data type into the config interface, and it will actually just magically appear as a YAML file on the disk for the administrator to configure with whatever fields your config type has. Like I said, wrong way, sorry. It automatically puts that on disk. So this is actually taken directly from the source code. One of my goals when I was like initially working on the plugin system prototype was really to make it the API sort of self-describing with documentation. So all of the types and functions and interfaces, et cetera, are very rigorously commented. And they very often will contain examples and descriptions of exactly how you want to use that. So the main sort of type that the plugin API exposes is this plugin type, and that's kind of what I just described. You see here there's a manifest, a config, and an initializer. And this code up here, this is actually an example plugin that's right now in master, included with Singularity. It's just in Sylabs Singularity examples, test plugin, something like that. And it's really, really straightforward to get the sort of rudimentary components of your plugin up and running. So you can see here, this is the initializer interface. This code is actually slightly incorrect. And then also here's the plugin that you expose. You have to expose it as the name plugin. Otherwise, we don't know how to find the plugin symbol. And then there's this plugin implementation type that you can see has the init method declared for it. Yeah. So right now, I took these pictures like an hour and a half ago, 2 hours ago, or something like that. This is right now in Singularity upstream. So there's a bunch of commands. There's plugin compile, there's enable, disable, install, uninstall, list. So the first command that if you're going to go out and experiment with plugins is compile, right? So you give it a path to the source code. This caused a lot of headaches for me, this command, because Go is really bad at building portable code as plugins. I don't want to bore anybody with the details, but long story short, your source code has to actually be you have to actually be within the Singularity repository right now. Otherwise, it doesn't work. Just the way it is. So this is that example that I actually showed in that screenshot earlier. You can see here there's this initializer. And what that initializer is doing is it's registering like a test flag with Singularity. And it gives it a default value as well. And there's a callback function. So eventually, right before we actually go into the container runtime, you'll get a function that we will call back into, and then you'll be able to modify the runtime parameters. And so this sort of hook right here is pretty good for probably like 75% of the things that people might want to do with a plugin. And I have a couple examples of things that we're planning on doing and we're already going to be doing soon, and also sort of the target release date for those plugins as well. And you'll see that for I think all of them except for one, this is enough here. This will do everything that they need to do. So again, you can do so after I did the plugin compile command, I did the plugin install command, and now I do a plugin list command. And so you see the name is sort of a fully qualified domain name, just for uniqueness that's not enforced. It's like kind of convention, but I would recommend you do that anyway, because you don't want to have any collisions with other plugins. And this makes it really easy to avoid that. You can also see there it says enabled yes. You can disable it, and it says enabled no. And then you can also, okay, so I re-enable it here, and then I do an uninstall, and I do a list again, and now it's disappeared again. So one of the things that I've actually really enjoyed about this user group so far is, so Dave mentioned at the very beginning that this plugin system was coming. And I've had a lot of people come up to me and sort of say, hey, we have an idea for a plugin. Can we work together to make this happen? Or, what kind of hooks do we have, or what can we do? And so I've actually have identified sort of 4 different things already that I'm anticipating are going to become plugins, very soon. So I was talking with Parav yesterday and today. We want to make like a RDMA plugin. So instead of, right now we have --NV for GPUs. What if we could do --RDMA for InfiniBand RDMA support? Just automatically mount in the OFED drivers that you need, the libraries, as well as the RDMA device. So there's GitHub issue open for that. If people are interested in helping us with that, you're more than welcome to go check out that GitHub issue. There's, I think Mellanox has a Go library for managing and kind of inspecting the RDMA devices, so it should be a pretty easy lift. Also there was a talk by Rosemary yesterday from Alexis, and we're sort of working with them to look at making a plugin for Mistral and Breeze so that you can do I/O profiling of your containers. Also a GitHub issue open for that if you want to help out. Oh, and I should mention I put the release dates here. So these two plugins targeting for like 3.2 to 3.3 maybe. Just kind of depending when we get to them or if someone else can get to them and help out there. And then another one, so Dave Dykstra and I, we were talking about, and we've been talking about for like over a year now, actually, having a CVMFS plugin so that you don't have to mount CVMFS on the host and then bind mount it into the container. You can just pass a CVMFS flag to the, to Singularity, and you'll just have some specific CVMFS instance mounted into your container. I'm hoping, I don't know, I haven't run this by anybody yet. I just put that in on my own, but I'm hoping that we'll be able to have that done by the CVMFS workshop, like June 3rd, right, Dave? I think that's a pretty, maybe ambitious, but I think it's also doable. And then also ORS, I think that stands for OCI Registry as Storage, something like that. So there's been some interest on our GitHub issues page about adding support for these ORS registries. And we thought it would be maybe a cool way to showcase the plugin system if we can add a custom URI hook into the plugin system itself. So that actually is some prerequisite work that has to be done before we can target this right here. But after we do that, there's also an issue open there on GitHub for doing the development of that work. And then you'll be able to push and pull ORS images directly, or CIF images rather, to like the Azure Container Registry as OCI format. That's really all I have. Just wanted to provide a quick update on a couple of things we're working on. Keith, you want to pass around the talking stick?
Hi, great. So just sort of going back to some of my experience with similar systems, are you thinking about providing essentially a plugin registry so that you don't end up with people creating plugins that have collisions in their expected kind of
well, great question. So actually one of the things, so everybody is hopefully familiar with the CIF format in 3.0. Great thing about CIF is that it's not just for, or it doesn't have to be just for storing like a SquashFS file system. You can really put arbitrary data in there. So actually, let's go off the script here a little bit. Second. Make it bigger, Mike. Good. So if you run the plugin compile command, it'll take a few seconds because I'm in a VM and it's on a laptop, so it's a little bit slow. But you'll actually see that these plugins are compiled as CIF in CIF format. And what that means is that you can also then push that to the library for free. And so that's actually the plugin itself right there as a CIF. So yes.
So going back to the Kubernetes aspect, and maybe this is something where I should have just spent more time on the website, but to get my head around the interaction between Singularity and Kubernetes, I have a Kubernetes cluster. I have Singularity containers. Does that modality work, or is this something where it's inverted and I don't understand it fully?
If I understand you correct, that's exactly what that will solve, right? Okay. So you have your Singularity, let's say you have your CIF images on the library, and you have your Kubernetes cluster. All you have to do is really swap out the CRI that lives on every node next to the kubelet, and you can just run them then.
Okay, and is this something that can live in parallel, or does your Kubernetes cluster become, at the moment, a Singularity Kubernetes cluster?
So I believe at the moment, this is not something that can live in parallel because that feature is in alpha from Kubernetes. So there is support for selecting your runtime at runtime. So I think you can like it is there? It is there.
Okay, so I can, all right, so but this also is not a user space application. It's something where I do need to work with the administrator of the cluster and say, I need this additional runtime so that I can execute Singularity containers, which for our case, we have.
Yes.
Okay.
So you have to install it as an admin in the same way that you would have to install Singularity as an admin anyway for the standard typical workflow.
Okay, awesome, thanks.
But after that, a user can then select which if they want to run on like the default CRI versus Singularity.